Okay, so seeing as how it's been quite a while since I've done an installment on the How to CNC series of my YouTube videos, I figured it was time to update that. And so what we're going to go through here is going to be explaining this part right here, which let me remove the stock. But here's the part, designed CAD CAM all in Fusion 360. And the part itself in real life is the base plate for these 40 taper fixtures right there. And so this is really going to kind of explain, it's not the most modern way to CNC, but it's the best way I've come to figure it out while using an older style machine such as this that doesn't have a tool changer on it. So unlike you would see on more VMCs where you can program, you know, one tool path, say like an adaptive that might use multiple tools or multiple tool paths that use different tools, and have them within one program via macros or just have programs linked together somehow. I have to go about it a little bit differently, since I have to manually stop and change the tools myself, even though I have an automatic tool changer up there, like pneumatic wise. I don't have to take a wrench up there, but I physically have to put my hand up here and remove this tool and put the new one in every time. So that makes it a little bit different than what you see on most how-to videos that kind of explain this stuff, that are using machines that cost as much as my house did, compared to how this one's the more like the price of a used car. But so I've already gone through and done all my cam for this before I even decided to make this video, so I'm not going to explain that here. I'm mostly just going to show the tool paths and the elements in Fusion I use to create those tool paths, explain that, and then show it in real time on the machine. Once again, I'm not going to show the facing operation right here in real time, because I didn't decide to make this video until after I'd done that. But as you can see here, once I have the stock added, which is this darker block right there, or kind of it goes all around it, right there at the top, that blue part, that would be the not the model top, that would be the stock top. The model top sits, I think, 0.01 below it or something, and so that's how much I take off in the facing operation, which, hold on, like I said, I'm not going to be able to show you this in real time, but I'll at least be able to simulate it here. So the first thing I did was this right here. It was just this facing operation, which is using a 3/4 inch 3 flute cuts like butter carbide tool. I use them primarily for aluminum, or strictly for aluminum. They do really good. But so there's the facing operation. There's really not much to explain there. But then come here to the adaptive one. This was done using the 3D adaptive up here. You got you can do 2D adaptive clearing or 3D adaptive clearing. This is done doing 3D adaptive clearing to generate this tool path. And so you got to input a lot of variables for the depth of cut you want and stuff like that. And eventually I'll get to kind of explain some stuff in later videos on how I go about doing that and how I figured out what my machine was capable of handling. But I'm not going to do that right now, because I don't want to make this video 3 hours long. I'm going to break it up into parts. And so this first one's just going to be showing the tool path, how it was generated, and then show it in real time how it gets cut. But so the simulation of what they generate from all my inputted variables comes out to be like this. And let me speed it up just a little bit so this doesn't take forever. And that's using the same tool that I used to face with also. Sorry, it's getting kind of out of the screen there because I have it set to move where it shows it moves more like it would in real life versus having the spindle move and the table sit still, which is easier to see, but it's kind of backwards of how it is in real life. But okay, so you can see there we've got the finished result from our simulation. Let me move this over, kind of go around and check that out. But yeah, I mean, looks pretty good. There's a little bit of extra material that got left here on this close and far sides, but it cut right where it needed to on the right and left sides. That amount of material right there is so minuscule, it just shows up in the simulation, but when I go to chamfer these things, you won't even be able to see it by the eye. And since this part is not something that's super high spec, I'm not even gonna go in there and worry about it. Same with some of this blue that's left up in there. If it was a part that needed to be, you know, more precise, I would change it, but because it doesn't need to be that way, I'm not gonna waste time doing it. But okay, so there's the simulation for that. I think in a previous video, back when it was the one, there was a super long video about how to program using a GSK control. I know I've mentioned that I've since upgraded to a servo orient control, which you can't really tell the difference because it's in the same housing, but it is a significantly improved controller for the machine. But it operates off of all the same electronics components in the cabinet. It's a Fanuc based system. I'm still using the Fanuc post program in Fusion for it. So nothing's really changed there other than my controller being a lot more user friendly and I believe to be a little bit more accurate. But so I'm not going to go through and describe exactly how you post process everything in there. Well, I mean, I guess I can for just the adaptive, even though I've already done it. But so I'm not going to do this for every other feature I have to do. But so you come here, right click on the toolpath, post process. This one, that's the number I had set for it, 4700. You can see I'm using the Fanuc post right there. For these adaptives like this, I believe I was using IJK versus force radius arcs. I tried to use force radius arcs down here for simpler cuts and for things that aren't making a complete circle. And since this has got some more complex maneuvers, and it's, I mean, technically not a complete circle, but it is a complete shape all the way around the way it does it. With the complex features, I do force IJK, which does make the program quite a bit longer, but I just get better results that way that are more accurate from it. And so I do my adaptive that way. Then come down here, this isn't correct, this is from a different toolpath, but I've been just kind of, since I got a CNC machine, I've always just been always use high feed rather than using rapids, because the older machines, the rapids aren't very high on it anyways. And I know that for this particular tool and what the feed is, it would be 26.8. All right, hit the wrong button there. 26.8. And then that would basically be it, other than when I make sure I'm doing force IJK, I make sure I have the radius arcs turned off and the allow 3D arcs turned off. So then I would just post process it, pull it up in a notepad file like this after that, and then I have a few changes that I make to the first 7 lines and the last few lines. That is something I've also gone over in the very first How to CNC video, so I'm not going to rehash all that, but that's just something that I figured out I need to do to make my machine operate with the controller systems that I've had on it. And it's just, once again, it was something that I copy and paste this from each program to each program, and the only thing I have to change ever is the speed of the spindle. And then at the bottom, I shorten up a few things with another copy and paste thing, so it's real fast. But that's how I go about doing all of that stuff. And so from here, I guess I'll clip in another part of the video where it shows the actual machining of this 3D adaptive toolpath, and then we'll move on to talk about the rest of these operations that involve different tools, and why I can't just do it all at once, and why I have to stop and do tool changes and such things like that. But okay, appreciate it. Okay, so I just manually implemented the tool change from the 3/4 inch 3 flute carbide tool to the 3/8 3 flute carbide tool for cutting aluminum, also made by Cuts Like Butter. They have both of them have nose radiuses on them. And so for the next operation in here, I do what is called bore 1 for me right there, which is going to come in and bore out these 2 holes that are basically counter bores for bolt head to go into. I'll show you that in the simulation of what that looks like. I may want to slow it down because I know this goes pretty quick. That might be too slow. Yeah, fairly simple operation. Just goes in, bores out these 2 holes. Okay, and so now we'll come over here and we will implement that on the machine in real time. Sorry, I had to stop the video for a second. I got kind of thrown off by all this stuff going haywire up there. That only happens to the video feed in my the camera on my phone, and I never noticed it before because I'm not seeing it through my eyes over the phone there, and it made me pause the video for a second to be like, what was I looking at? But okay, so now we will go to Edit, Program, Local Directory. We go one more down, Open, go up 1, Auto, 100%, and just to make sure I know I have the right tool in there, I know that this tool is HO2, which shows up right there in line 10 or line number N9 of the code. So I know that I have the right one. So then I'm already up there, highlighted the line, input, cycle start. Hole 1 back there, got some chips in it. Hole 2 right up front right there. Okay, so up next is the chamfering toolpaths. And the reason I say toolpaths is because I break it up into 3 separate programs, and that's probably not the most efficient way to be doing this, but as someone who is self-taught in CNC machining and using Fusion 360, and along with some of their more recent updates that I'm not the most stoked about how they operate, I'll explain exactly why that is. So if you come over here, I'll show what happens if I were to program the outer chamfer in just one cut, what would happen here. And this is what I'm not the happiest about in Fusion, is how when I come here, this whole if I can get the glare off my light to stop showing it. This whole contour selection box thing, maybe it's just because I don't like change and I got used to how it was before, but I know it's there to improve the usage of Fusion 360, but I feel like it has some unnecessary stuff. I was so used to the way it was before. But okay, so let me remove my stock model real quick. Okay, so if I select the entire outer chamfer here, and I do this all with a 2D contour, we will okay that. Hold up. That was something that was previously set from the way things were originally. I just changed it for this part of the video, so let me make sure there's nothing else I needed to. I think that it was this right here. Yep. And that needs to be 90. Okay, yeah, so that's good now. But you'll see what happens here whenever I run the simulation. If I do it all in one continuous toolpath. We're going to be focusing on the corners, how it basically rounds the corners of the part, which isn't necessarily a bad thing, but it's not what I'm telling it to do. I've gone through a lot of the variables and the settings of the programming and have not found a way to get it to do that without breaking it up into like specific cuts or straight line cuts or just like specific cuts. But if I try to do the whole thing in one continuous cut, I have not found a way to be able to unround those edges, even with the make corners sharp selected. But so here's going to be a simulation of what it does as one solid toolpath. Okay, that's going a little fast. I'm going to have to run this twice. But okay, you'll see right here. So if it comes in, rounds that cut right there in the red. Rounds that cut there in that corner. Does the interior of this little horseshoe just fine. Rounds it right there though. So it did that one over there. It rounds all these sharp corners without being told to do so. And I haven't figured out how to do away with that unless I break this, what could be a continuous toolpath, up into two separate chamfering programs and then a third that does the chamfering on these bolt holes right there. And so we'll exit this simulation and go back over to how I actually program it right here. And so this will be the first simulation of the three. Get this out of the way, damn it. Sorry, I'm gonna restart this because that was crowding things. Okay. So it comes in for the horseshoe, goes up, comes and does this near side in a straight line, comes up, goes down to do the other horseshoe in a cut, and this is all within one program. Comes up, does this back side in one straight line. So that would be one program right there. The second program comes and finishes the right and left sides in straight lines. So okay, we're hitting that left side. Sorry, it's not the best angle. We'll get to make up for it on this right side. Comes in a straight line, cleans that up so every corner stays sharp like I intended. And then, like I said, lastly, I do this third program. Oh, that was post-process, not simulate, which is just to add the chamfer to the bolt holes right here. And now, I will be the first person to say that as someone who has taught themselves how to do all of this on their own, I am 100% positive there's a better way to be doing this that's more efficient and is making up for or correcting all of the things I am saying why I do it the way I'm doing it. But this is just how I figured out how to do it on my own. With playing around with it, I've kind of fell into the trap of knowing how to do it this way and haven't branched out too far to expanding my knowledge in the CAM portion of things. Like, that's on my to-do list to where I can make my programs more efficient. But since I figured a way how to do this early on, I've kind of just stuck with it. And when I have more time, I'm gonna start optimizing the toolpaths more like I need to be, with the exception of the tool change issue of my machine. But one thing that I will note here is that for these chamfer contours, that because they're all done in 2D, the only one of these programs there that was done in 3D was the adaptive. And so if I come over here to the part, you can see how, which will have previously been shown in the video, the final cuts of the part in the adaptive program actually did remove some material, as if it wasn't actually chamfering, but it was removing the material it could for the chamfer, just because it was part of the adaptive. And so you can see where the chamfer will be around that, but I mean, there might be a way you can just remove it. It's kind of unnecessary to even do that, but it just, the adaptive generates it in the toolpath. I just, it's like an extra 45 seconds. It'd take me longer to figure out how to remove that out of there, so I just kind of keep it in there. But once this comes through with the chamfer tool, that'll be all cleaned up into a solid chamfer all the way around, instead of having those little steps that it kind of leaves there from the adaptive. Okay, and so that's really all I'm going to show for this video, because the only things left to do to this part besides flip it and deck off the leftover material at the bottom and then just rerun the chamfers is to drill the bolt holes in here and the center of the holes that go through that counterbore hole. And once again, probably one of my not best habits that I've developed by having this older machine and, you know, getting acquainted with machining on that old girl over there. But I have a tendency to just type in the locations of the holes and then drill them in a manual cycle rather than having it programmed in there if it's just punching those holes in there. But I can still get them accurately located by just knowing the machine coordinates. But eventually, like I said, I've got a long ways to go with optimizing my programming to the best of what I'm capable of on this machine. If I had a different machine, I'd be a lot more focused on that. But this is just kind of showing how I do it with what I have.